So our last assignment was a pretty long video. Hopefully this one won't be as long, but we really needed to review how we found the area of composite shapes. This one we're going to add on to one of the practice problems that I had you do with the last lesson, and then how we go a step further. Sometimes we're going to be asked to calculate a cost of something from the area given, and then sometimes not are we going to just find the area of an entire shape, but we'll find the area and then take pieces away. So that's what you're going to be seeing on these practice problems, and then you'll have your assignment to do, and there will be 6 questions. So please be sure that you're following along. And if I go too fast once again, pause, write it down, rewind, whatever you need to, watch it 4,000 times so that you can enjoy your math. So we're going to start with this shape that we did in the previous lesson, right? It says, so the Jamesons hired a landscaper to create the walkway shown. And I had you find the area of this composite shape. So we're going to review that real quick. And I'm going to go a little faster than normal for this particular process because you should have gotten to this answer. So as I'm looking at then, the first thing I had to notice was that there are 2 distinct shapes that make up this composite. So hopefully you saw there's a parallelogram and that there is a trapezoid, which means then we had to use our reference sheet to figure out what our formulas were that we're going to use. So we're going to start with the parallelogram. So the area of a parallelogram is found by doing base times height. When I look at that rectangle at the bottom, which once again is a parallelogram, then we can use the 6.3 as the base and the 4.2 as the height. Now, if you switch those around and you say that the base is 4.2 and the height is 6.3, it doesn't matter because I can multiply in any order that I put them in. So I stack my decimals and I begin my multiplication. So when I have 6.3 times 4.2, I start with the 2. 2 times 3 is 6, and 2 times 6 is 12. My second number tells me to bring down a 0, and then 4 times 3 is 12, carry the 1. 4 times 6 is 24 plus 1 is 25. I add the products together, and I get 6, 4, 6, and 2 with 2 decimal spaces in my math problem, so I move from right to left 2 times. So the area of the parallelogram for this math problem is 26.46 square feet. Then I have to look at the trapezoid. Now on the trapezoid then, hopefully I can tell that that base A or base B, whichever you want to look at, is going to be the same measurement as the base or the height for the rectangle. So I'm going to use that 4.2 and then use this 13.65 for the 2 bases. So area of a trapezoid is base A plus base B divided by 2, all multiplied by the height. So when I plug in that information, then I can see that my height is also 4.2. Well, that doesn't change my math problem, right? I see the right angle, I see the height, so I'm just going to plug in the information. So when I create my equation, 13.65 plus 4.2, base A plus base B, all divided by 2, multiplied by the height of 14.2, then I can do the math to find the area of the trapezoid. So when I do that, then I want to do step by step. I have to start with doing my numerator and finding its total value or its sum. So I'm going to stack my decimals. 13.65 plus 4.2, my decimals lined up. I bring down my decimal and fill in with zeros. When you added those in our previous lesson, then you should have gotten 17.85. If you got 17.85 as your numerator, then hopefully you said, well, my next step is I have to divide by 2 because order of operations tell me to do multiplication and division from left to right. And I know that 17.85 over 2 is division. So you should have done 17.85 divided by 2, raising your decimal, and then 2 went into 17 8 times, which 8 times 2 is 16, with a remainder of 1. You brought down your 8, and 2 goes into 18 9 times, which is 18, and then brought down your 5, and 2 went into 5 2 times, which is 4. But with the remainder, you had to add a 0 and bring it down, and you should have ended up with 8.925. So what we're found out then is if I took base A plus base B divided by 2, my new equation that I'm solving is 8.925 times 4.2. Once again, I got to. So then, once we found that the base A plus base B divided by 2 is 8.925, and I'm multiplying that by my height, then I have to stack those and multiply. So then you should have started with multiplying by your 2's. 2 and 5 was 10. 2 times 2 plus 1 is 5. 2 times 2 is 18. And 2 times 8 plus 1 is 17. Your second number told you to bring down a 0. Then you multiplied by your 4's. And 4 times 5 was 20. And then 4 times 2 plus 2 was 10. 4 times 9 plus 1 was 37. And 4 times 8 plus 3 was 35. All right. So now we end up with our two products, and you add those together, and you should have gotten 0, 5, 8. 7 and 7 was 14. And then 7 and 3 with hopefully 4 decimal positions when you did your math. So you found out that the area of your trapezoid was 37.485 square feet. Then you added those together. And when you added those together, hopefully you dropped your decimal and filled in with a 0, and then you just added your columns. Right? So you got 5 and 9 and 3 and 6. So this is where everyone should have gotten yesterday, and most of you brought me your papers. So you should see on your note paper that I've given you all the steps that you should have gone through to get to the step where we have the area of the composite shape. Because today's lesson is adding on to lesson 1, and that is taking it a step further once I know the area of the composite shape. So the question that's in your book is, if we're going to have this walkway and it's going to be covered with decorative stones that cost $25 per case, and each case will cover 6 square feet, what do I do with that? So what I do with that is I take the overall area and I'm going to put it in groups of 6. Now, we could go through and get an exact answer, but I want you to think about when you go to the store to buy things, right? You can't go in and buy 10 of the item and then a partial item, right? You can't go in and say, well, I need a package of socks. They come in packets of 8 pairs, but I only need 5.5 pairs. So I'm going to take out 5 pairs and 1 sock and leave the rest in the package. That's not going to happen. So I just need to look and ask myself, well, how many groups of 6 do I need to get? Or can I get? What's the most? So 6 will go into 63 10 times, because 10 times 6 is 60. Now, if I wanted to go ahead and divide, I'd get 10.6. So, but what I know is that I have a decimal point. That's my point of bringing that up, because if I just buy 10 cases, then I'm going to have some of my walkway that isn't covered. So how many cases do I have to buy? Hopefully you said 11. So if I take the 11 that I have to purchase and then I multiply it by $25, I can then get to my final answer. So when I multiply 1 by 25, I get 25, and my second number tells me to bring down a 0. And then I multiply 1 by 25 again and get 25. So what I see is if I purchase 11 cases, and that's going to cover, each case is going to cover 6 square feet, and I'm going to have to cover 63.945 square feet, then I'm going to spend $25 for 11 cases. So I spent $275, right? So most of that work we did in our previous lesson. The step today was just taking it a step further and being able to find a value if I'm being charged for a certain area. The other thing that we need to go a step further is not only can I find areas, but then I can also use these in a subtraction problem. So I'll go a little slower on this one because this is going to be some new steps to it when we do it. But this is a new problem, should be on the back side of your paper for your notes. So when I cube up my question, it says I want to find the area of the shaded region. right? So area is important. I know what I'm finding. I'm finding what will fill it in or what I'm taking out. And I know it's the shaded part, so that would be the blue in your book. I can see that I'm using 3.14 for pi with my circle, which they're making your life just a little bit easier. And it says that if I have to, I need to round to the nearest hundredth, and we reviewed how we round on the previous lesson. So let's go through the idea of how I'm going to solve this. So first, I'm going to find the area of a parallelogram because there's a square there, and then I will find the area of a circle, which we reviewed in our previous circle lessons, and that is pi r squared. When I look at what I'm given, starting with the parallelogram, I've given a square, right? Squares are opposite sides are equal, there are right angles, but it has two sets of parallel sides. So I know that it is still a parallelogram, and therefore I'm going to use that formula. But they only give me one measurement, and that's okay, because that one measurement just gets duplicated since it is a square. So I know that in the back of your planners, you're going to see that the area of a square is s to the second power, or s squared. And all that's saying is that if I have the same measurement because it is a square, I'm still multiplying it side by side, or it's base times its height. So don't let s squared confuse you. It just means I'm still multiplying base times height because it happens to be a square shape. When I do my 8.5 times 8.5, once again, if I'm showing it, please write down your notes so that you have good resources to look at when you're doing your homework here in a few minutes. Start with my bottom right, multiplying by 5. 5 times 5 is 25. Carry your addition of 2. 5 times 8 is 40 plus 2, so you get 42. Your second number tells you to bring down a 0, and now you're going to multiply by the 8. 8 times 5 is 40. Put down a 0, carry your addition of 4. 8 times 8 plus 4, so that is going to be 68. I have my two products. I'm going to make sure they're stacked up neatly. I'm going to add going from the right to the left. And so I have 5 and 2. 8 plus 4 is 12. Carry that addition of 1. And then 6 plus 1 is 7. Multiplying decimals, I have to look at my decimal spaces in my math problem. There are 2 of them. So I have to move my decimal from right to left 2 times. So once I've done that math, then I have found that my area of my parallelogram is 72 and 25 hundredths square meters. Now I use my formula for area of a circle, pi r squared. And they tell me in the math problem that I get to use 3.14 for pi. But now I need to figure out what the radius is. Well, the radius, once again, by definition, goes from the center out to the edge of a circle. So they're showing you the radius here is 6 meters. So that's the measurement I need to use. I plug it into my formula and I write my equation. This is where some of you are getting yourself all mixed up because you don't want to show this step. So now I have that 3.14 times 6 squared. And 6 squared, once again, means 6 times 6. It doesn't mean 6 times 2. And 6 times 6 is 36. So I write that into my equation, and I have 3.14 times 36. And I do my multiplication starting in the bottom right with my 6. So 6 times 4 is 24. Put down my 4, carry my addition of 2. 6 times 1 is 6 plus 2 is 8. And 6 times 3 is 18. My second number tells me to bring down 1 0, and then I multiply by my 3. 3 times 4 is 12. Put down my 2, carry my addition of 1. 3 times 1 plus 1 is 4, and then 3 times 3 is 9. When I add my products, I get 4. 8 and 2 is 10. Put down my 0, carry my addition of 1. 8 and 1 is 9 plus 4 is 13. Put down my 3, carry my addition of 1. 9 and 1 is 10 plus 1 is 11. I look back at my math problem. I multiplied with a decimal, so I have 2 decimal spaces, and I'm going to move from right to left 2 times. So I'm finding that the area of my... So when I see that my overall circle is 113 and 400ths, then I have to remember what I'm being asked to do, right? I need to find the area of the shaded region, right? So only the blue part. So that means I have to take the square's area out of the circle's area. So I have the larger number, and I'm going to subtract the smaller number. So when I subtract decimals, once again, I line up my decimals, and then I bring it down, and then I can subtract. And I can't take 5 from 4, so I have to borrow. I'm going to have to go all the way over to the 3 and borrow from it. So when I borrow from the 3, it becomes 2, and I carry over a 1 to the 0, which makes it a 10. But then I still have to borrow. So that 10 is going to become a 9, and I carry a 1 to the 4, which makes it 14. And now I can subtract. So 14 minus 5 is 9. 9 minus 2 is 7. Well, 2 minus 2 is 0. And 11 minus 7 is 4. So what we see is the area that is shaded, what's left over in the circle when I remove the square from it, is 40 and 79 square meters. Don't forget your label. Right? So we're just taking it a step further and being able to do other things with it other than just finding the area of composite shapes. So if you have any questions, please ask. Don't get stumped and sit there and be confused. But now that you've taken your notes on today's paper, I want you to do your assignment. There are 6 questions, 2 through 12, the evens. And if you've followed along in the past 2 lessons, then you should have great examples that'll show you what to do. If you have questions, please ask us. We are here to help you.